Hello everyone, myself Jyotiranjan Mohanta, and today we'll start a new journey. Actually, this is the first time I'm going to recording a video, or the first video I'm going to upload on YouTube. So please, if any mistake, if I do, please give me some suggestion that I can improvise later. So since I'm from chemistry background, so we'll discuss some chemistry important topics. Okay, or chapters, important topics we are going to discuss. So the first class today we are going to take, and the topic includes acidic character, which is one of the very important and one of the basic concept. So so let's start. Okay. So what is basically the acidic character? Suppose we take a acid like suppose we take HA is our acid, and there are three acid-base concepts right? So one is Arrhenius theory, Lowry, Bronsted acid-base theory, Lewis acid-base theories. So what are the those theories? I'm not going to discuss, but according to the top two, like Arrhenius and Lowry acid-base theory, it is telling the acid which donates the H plus or which releases the H plus are called acids. So similarly here also happening, the HA is releasing a H plus, so it's a acid definitely. Okay, now you should know that how this H plus is releasing. It's a very confusing for 11th 12th standard students. Even when I was my plus 2, I was also this doubt, because now remember, this H plus is a proton. There is a different type of hydrogens are present. H plus is a proton. Hydrogen, simple hydrogen is called hydrogen, and H minus is called hydride. Okay, now you should know that how this H plus generated. Now, since this HA is a covalent molecule, covalent molecules means the bond formed between this H and A are covalent bond. Okay, so the bond formed between this HA and is the covalent bond, which is the sharing of electron. Okay, the bond formed by sharing of electron. Now, since these are sharing of electron, okay, this electron is of A, and this electron is of this electron is of A, and this electron is of hydrogen. Now what happens? Now this A, suppose anyhow this A is takes this his own electron, and also takes this hydrogen electron. Then what happens? This A is taking its own electron as well as it is taking the electron of hydrogen. As a result, what is happening? This hydrogen is losing its own electron also. Okay, so similarly, so in this way, this since it is losing its own electron, here H plus generating. Since this A minus is gaining one extra electron, here A minus generating. Okay, I hope you understood. Now, since again, Lewis acid-base theory also telling any species which can donate electron are called bases, and any species we can accept electron are called acid. Similarly, here also possible. This A minus can donate electron to this H plus and can become HA again. So this is a reversible reaction possible. When this donates electron is called acid. When this when this donates electron it will be base. Okay, now this base formed from what? This HA. That is why it is called the conjugate base of HA. Okay, I hope you understood these terms. What is H plus, what is conjugate base? Okay, suppose let's discuss about the stability of HA and A minus. Okay, suppose let's suppose the stability of A minus is more than HA. Let's suppose. Okay, now you know very well that in this world everyone wants to be stable. Each and everyone wants to be stable. Okay, that means what happens here? Suppose A minus is more stable than HA. Now in this equilibrium, you see this equilibrium, this HA also will try to become A minus. Yes or not? Because A minus is very stable, this HA will also try to become A minus. And how this one will become A minus? When it will release this H plus. Yes or not? When these two electrons will go to A, then it will be A minus. Na? When these two electrons are going to A, here H plus is generating. Yes or not? That means when it is becoming A minus, so simultaneously H plus also reducing. Getting? So that means when A minus will be more stable, more amount of H plus will be released. So H plus release will be increase. Now H plus amount increasing, that means the acidic character increasing. Getting? So here the stability of conjugate base, that means directly proportional to the acidity. I hope you understood. Okay. Now one more, okay, I hope you understood the acidic character. This is the simply basic of acidic character. If your conjugate base is stable, then your compound will be acidic. Okay. Now again one more thing. One more thing, let me tell you. Suppose the now you should know that A minus, okay, this A minus, this minus charge, it is like a weight. Okay, so this is like a weight. You have to remove this weight. Okay, now suppose this is you, your capacity is to carry 30 kg. Suppose your capacity is to carry 30 kg in your uh, head, okay, or in your back. Suppose I am giving you 50 kg, can you carry? No. Okay, because your weight is now increased, a little bit difficult than before. Okay, that means here stability reduced. But if I give you 20 kg suppose, then what happens? Your stability will increase, now less amount of weight. That means if amount of weight on my species is less, that means it can carry the negative charge, it can hold the negative charge. That means its stability will be more. Okay, if I am giving you more and more amount of negative charge or more and more amount of weight, then stability will definitely lesser. Okay, so that means suppose this A minus species, with this A minus species I uh, put a electron withdrawing group. That means it will pull electrons toward itself. As a result, what will happen? The amount of electron on this A species will reduce. Okay, that means the weight on this A is reducing. That means this species stability is getting increases. Similarly here, this electron donating group, this one donates electron to A minus. That means it is increasing amount of electron on A. That means weight on A is increasing. If weight on A is increasing, stability will reduce. Okay, so which one will be more stable then? Electron withdrawing group stabilizes the conjugate base. Okay, I hope you guys understood. Next, as I told, acidity is directly proportional to the stability of conjugate base. Okay, now let's discuss some examples. Now see here, this is the one period element, methane, uh, NH3, H2O and HF. Now what is your procedure is to find which one is more acidic. Your procedure first have to make their conjugate base. You make their conjugate base, it is CH3 minus, means when you release one H plus, then what is generating is called conjugate base. Okay, now when you release one H plus, okay, when you release one H plus, okay, when you are releasing one H plus, you are getting CH3 minus. Similarly, when you are releasing one H plus, you are getting NH2 minus. When you are releasing one H plus, you will be OH minus. Here you will get F minus. Okay, so which one will be more stable? Now here one concept come, that is negative charge on more electronegative atom is more stable. Why? Because electronegative atom, they wants to pull electrons towards themselves. It means they want negative charge, they want weight. Okay, that means now among these cases, the negative charge on carbon, here nitrogen, here oxygen, here fluorine is more electronegative than all. That means electronegative, that negative charge on fluorine will be more stable than oxygen, than nitrogen, than carbon. Okay, that means which one will be more stable? Definitely fluorine is more stable as compared to this oxygen one, then nitrogen one, then carbon one. Okay, if this one is more stable, which one will be more acidic? Definitely HF will be more acidic than water, then NH3, then CH4. Okay, I hope you understood. Now next, example number 2, among these two, which will be more acidic? Now first of all, make their conjugate bases. Now here one more concept come, that negative charge on more stable if it is present in a bigger size atom. Okay, you can see here the negative charge on iodine, here negative charge on bromine, negative charge on chlorine, negative charge on fluorine. because here negative charge is present in iodine, which has bigger size. It is more stable because now since it has bigger size, the negative charge can move on that bigger size very nicely, or you can say negative charge can move around here and there. Okay, that means if it is moving here and there, that means you can say the weight on iodine is little bit reducing. Okay, that means this iodine is more stable than bromine, then chlorine, then fluorine. Okay, that means which one will be more acidic? Hi will be more acidic than HBr, then HCl, then HF. Okay, so I hope this also you understood. Now let's go to next examples. This one example, see, same process, make their conjugate bases. So this is the conjugate base, which one is more stable. Now you can see here chlorine is present, and this chlorine is a electron withdrawing group. That means it is pulling electrons to ion itself. As a result, the negative charge on oxygen is reducing, but here CH3 is present, which is a donating group. Okay, since it is a donating group, the negative charge on oxygen is increasing. It is very unstable. Since this one is stable, this conjugate base is stable, this will be more acidic. Similarly here, acetic acid and formic acid. Acetic acid is a in acetic acid CH3 present, which is a electron donating group, but here hydrogen is not a very good donating group or not a very electron withdrawing group. Okay, so what happens, since it's a donating electron, that means weight on oxygen is increasing. That means this is very unstable. And as compared to this acetic acid, formic acid, its conjugate base is more stable. That means this will be higher acidic. Okay, so okay, now I hope you guys all understood the concepts of conjugate acid. So these small topics I will cover, and tell me, as I already told, this is my first video, and if any mistake I did, please inform me so that I can improvise on upcoming videos. Okay, so thank you for cooperating up to this. Okay, so see you soon guys, thank you so much.